Hi there, welcome to another episode of building the Flappy Dash game. So as you know, in this series we are implementing a game called Flappy Dash. It is just like the FlappyBird game, but we just replaced the bird with the dash, and we started implementing it using Flutter and Flame game engine from scratch, and this is the fourth episode. So if you haven't watched the previous episodes, I highly suggest you to pause the video and start watching the previous videos. So in this episode we are going to implement the player movement and specifically the jump behavior. As you remember, we have a dash, it's here, so it extends a position component, and to see what is the position component you can just take a look at the documentation in the Flame engine. So here we have the position component and it has some properties such as position, size, scale, angle, and anchor. So these are the most important properties that you have in a game component. So using the position, you can move the player around the map, and you can show the player using a size, for example 10 by 10 or 80 by 80. And also you can scale the player or the component based on this value. And also you have angle, which helps you to rotate the component. And also we have anchor that it is something like this. So it determines from which point of the component Flame engine should grab the component. So for example, it is top left for the blue one. It means that the Flame engine grabs the component from top left. If it is top center, so it grabs it from the top center. And if you set it to center, it is exactly grabbed from the center point. And also it works for the rotation. For example, if you try to rotate the red square, it rotates from the top left point. So it rotates from here. And yeah, so these are the most important parameters. So if we take a closer look at the position component, you see that we have position, size, and scale. These are vector 2. And also we have angle and anchor. That angle is a double and anchor is an enum, I think, or a class, something like this. So we have top left, top center. It is just like alignment class that we have in the Flutter. And yeah, so by the way, the position and size and scale are vector 2, and a vector 2 contains x and y. So basically it holds these two variables, and it has some helper functions. For example, you can copy it, you can generate a random vector 2, you can change the values. For example, you can set the x and y using the previous reference. For example, in sometimes you don't need to create a new vector 2 per frame, because if you have a lot of objects, they need to be cleaned up and it adds a lot of load on the GC, and that's why sometimes you need to reuse the same vector 2 that you have. And using this method, you can just use the previous instance instead of creating a new one every time. And yeah, so here we have the position on 0 and 0, and in the update method we can change the position. For example, we can say position plus equals vector 2 of 0 and 1, and if you hot reload, you see that it goes down, and if you try -1, it goes up. Yeah, so as you know, this is 0 and 0. If you go left, x value decreases. If you go right, x value increases. And if you go top, y value decreases, and on the bottom, y value increases. So this is how Flame engine works. Okay, so let's talk about the DT variable. As you remember, we have an update method or update callback, which is getting called in every frame. And DT is the stand for DeltaTime, and it is the time that is passed since the last frame. So for example, suppose that you have a system with 10 frames per second. So this value is gonna be 0.1, means 100 millisecond. Or if you have a system with 5 frames per second, it's gonna be 0.2. It means 200 millisecond between each frame. So what can we do with this variable? So suppose that you want to move your player by 20 points in each frame, and if you run this code in a system with 10 frames per second, it's gonna be twice faster as a system with 5 frames per second. So it doesn't feel consistent. You know, the movement is faster in a system with higher frame rate and it is slower on a lower frame rate machine. So that's why we need to multiply this value with dt. So this way, no matter how much frame rate do we have the same amount of movement in all the systems or all the hardware. So the only point is that if you run it in a higher frame rate system, it's gonna be smoother, not faster. So this is the point. Always multiply your movement by this value, by this dt, if you want to move your player or if you want to rotate it. So you need to multiply it with the dt to make sure that it is consistent in every systems with every frame rates. Okay, now let's implement the movement functionality and the jump function. So I'm gonna define a vector2 that is called gravity. So this is the value that pulls down the player towards the bottom of the screen, and it's gonna be vector2 and x gonna be 0, y is gonna be something like 10, for example. We can see how does it look like, and let's make it private. And now let's define another variable called velocity. So it determines how fast, in which direction the player should move. So it determines the movement. We are gonna set 0 and 0 by default. And in each frame, we are gonna update the velocity by gravity. So we are gonna add the gravity to the current velocity, and we need to multiply it with the dt variable. So this way we make it consistent over the different hardwares with different frame rates. And now we need to change the position by velocity. So if you run the app, yeah, you see that it's going towards the bottom. So I think this number is good for now. And if you run it again, you see that it goes bottom. And now we need to add the jump function. So we are gonna define it here, and we are gonna define a new variable called jump force, something like that. And we can say that we don't want to add any force in the x-axis, but we are gonna add minus 40 on the y-axis. So we can tune these numbers later, but let's see. Here we can just change the velocity to the jump force, which is a value that is negative. So it means it moves the player towards up, and then the gravity pulls it down again. So it pulls down the velocity, and here we just moves it up, and the position is getting updated using the velocity. Oh, by the way, we need to add the dt also here. And to implement the jump, I'm gonna show you the inputs here. Yeah. As you see in the Flame documentation, we have some inputs, and the thing that we are gonna use is tap callback. So it is simple. You can just add the tap callback, and you can override the on tap up or on tap down callbacks. For example, we can just add it to the game. If you remember, we have a Flappy Dash game here, and here I'm gonna say with tap callbacks. So let's import it. And if you have this mixin, you can override one of these methods. So I'm gonna override the on tap down here. And yeah, by the way, let's add it in the word because we have the reference of dash in the word. And here I'm gonna say on tap down, let's jump. So to do that, we need to have a reference of the dash that we have created in the onload method, and I'm gonna keep a late reference of dash, and it's gonna be the dash that we just created. And here we can just say dash.jump. Oh, let's make the jump force private. So yeah, and we can just call the jump, and I hope this works. Let's see. Okay, as you see, the gravity is working well, and if you tap, it jumps, and again the gravity pulls it down. So we need to increase the parameters here. Oh, it is slower because we just added the dt here, so we need to increase it to 200 to see how does it look like. Okay, let's increase the jump force by, for example, 150. Okay, we need to increase the gravity by, for example, 700, and increase it by 400 maybe. Yeah, so I think we need to increase the gravity by 900. Yeah, I think now we are good with these numbers. You know, the point is that you need to play with the game and tune these numbers. And now I think we have some perfect numbers here, 900 and minus 400. And yeah, it works well, I think. Okay, so in the next step, let's add the jump function with the space button in the keyboard. So if you run the game on the PC or on a web, so we want to be able to jump the player using the space button. So here in the inputs, we have keyboard inputs. So you just need to implement the keyboard events, and then you can override this function. And here there's a logic that is called if key pressed contains a space is true. And here it said that if event is key down event, so this combination makes sure that the user pressed a space and it is key down, and this way we can jump the player. And yeah, so I think this is exactly what we want. I'm gonna add it in the flame game. It's here. And yeah, I think the point is that you need to have the keyboard events on the game to be able to catch the events. By the way, here we can just copy paste the code from here, and let's import them. Okay, so it says that if it is not a space and key down, let's ignore the key event. And here I'm just gonna call the jump function. So we are gonna jump here. But the point is that we are in the game, and here we have the dash in the word. So I'm just gonna add a function here called on a space down. So this way we can have access to the word here. Yes, and we can just call on a space down. And here we can just get the event and do whatever we want. So for example, we want to jump the player. Okay, now let's run the game to see how does it look like. Yeah, so I can jump the player using tap or the space button in my keyboard. And yeah, so the point is that we are not moving the player horizontally, we just add the gravity and jump force. And also on the background we have parallax effect, we just move the image. And in the next episode we can just add some pipes that are moving from the right side of a screen to the left. So it feels like that the bird is flying, but the point is that it is not flying, it is just in the same X position, but the pipes and the background is moving. So that feels like the player is, or the dash is flying towards the game, but it is not. It is just the same X position and we just move the pipes. And yeah, so I think we are done with this episode. And don't forget to hit the like and subscribe button, share it with your friends who like to build a game. And in the next episode, we are gonna implement the pipes and also some collision detections to detect when the player or the dash hits the pipes. So this way we can implement the game over logic and scoring system. And yeah, so stay tuned for the next episode. Bye.